We are going to start now the chapter 14 of class 9th mathematics statistics, and this is lecture 2. Now in this lecture we will talk about bar graph, histogram and frequency polygons. In the previous lecture we have discussed about what is some basic terms related to statistics, that is data, then class size, class limits, then the frequency, then cumulative frequency. We have seen these terms. Now the next term we are going to do is the representation of data in the graphical form. So we will talk basically about bar graph, histogram and frequency polygons. So graphical representation, we mean to say that in the previous lecture we have arranged the data in the tabular form. Now from that tabular form we are going to represent the data on a graph, so that by looking at the graph we can tell we can know or we can tell the information about the given data. So the first thing we are going to do is bar graph, or it is called the column graph. The first topic we have is bar graph or the column graph. So if we look at the definition of bar graph, it is, we are saying that the bars of uniform width are drawn with various heights, and the height of the bar graph represents the frequency of the corresponding observation, and same space is left between the consecutive bars. So we will see with an example what a bar graph is. So suppose 70 students from a locality use different modes of transport to go to school, and the data is given below. Now this, we are talking about mode of transport. This first row we are talking about, these are car, bus, scooter, bicycle and rickshaw. And number of students we have, that how many students use car, it is 4, bus 27, scooter is 11, bicycle is 20 and rickshaw is 8. So we have to draw the bar graph. So to draw the bar graph, we have taken along x-axis the number of the mode of transport. So x-axis we are talking about. What we are going to do is we are going to draw two perpendicular lines over here. On the graph paper we will draw two perpendicular lines. This axis we are saying this is the x-axis, and this axis we are saying this is the y-axis. Now x-axis we have marked at equal distance these things: car, bus, scooter, bicycle and rickshaw. These are the modes of transport. They are represented on the x-axis. And on the y-axis we are talking about the number of students. These are the number of students that are represented on the y-axis. Now how these points are marked, we are saying the minimum value over here it is 4 and maximum value it is 27. So we need maximum up to 30 points. So we mark the points at 5 unit distance. We mark these points, it is 5, 10, 15, 20, 25 and 30. These all points we have marked at equal distances. So what is given to us is that number of students using the car. So at car we have drawn this rectangle over here. Now we know that the frequency over here it is 4. So we have this, the height of this bar it is up to 4. Next for bus it is 27. So 27, this is 25, 26 and 27. So this point over here, this is representing the height 27. So for the bus we are saying we have marked this box over here. We have marked this box over here and we are saying this is representing the bus. Next we are talking about scooter. It is represented over here at the height 11 units. Then it is bicycle. Bicycle is at the height over here, this is 20 units. And then last we have it is rickshaw. This box we have constructed over here, or bar we are saying it is, we have constructed up to the height of 8 units. So this is what bar graphs represent. We are saying this is first one bar, this is second bar we have, this is third bar, this is fourth corresponding to bicycle, and this is the rickshaw fifth corresponding to rickshaw, and their heights they represent the frequency of the corresponding mode of transportation. Now in this next example we are saying there are 840 creatures in a zoo, and we have listed them as below. We are saying that beast animals, these are 120. Then other land animals, these are 345. Birds 165. Water animals 135, and reptiles 75. So we have to represent it on the bar graph. So same thing we are doing over here. We have drawn two axes, two perpendicular axes first. Next, this axis we are saying this is x-axis. This we have marked over here, and y represent this is y-axis. On the x-axis we have marked these creatures types over here, that is beast animals, other land animals, birds, water animals, and reptiles. All these they are marked at equal distances. And then we are talking about, we have to draw the number of creatures on the y-axis we have to represent. So the values we have over here, the minimum value we have it is, we are saying it is 75, and the maximum value we have it is 345. So what we can do is we can mark the points at the distance of 30 units. You can mark at 50 units also. So the first we are marking 30, 60, 90, 120, 150, then 180, 210, 240, 270, 300, 330, and 360. You can also mark the points on the y-axis as this is 0, then it is 50, this is 100, this is 150, then it is 200, then 250, then 300, and then 350. The maximum value we know it is 345. It will lie somewhere over here. So you can also mark these points in this way. Now we have to draw the bars over here with these heights. So for the beast animals we are saying the height is 120. We have drawn this bar over here, and the height over here it is 120. Then we are saying other land animals. So for this we are saying the height is 3, 4, 5. This height we are talking about, this is 3, 4, 5. This point it is up to the height of 3, 4, 5. Next we are talking about the birds. So birds we have drawn up to the height of 165. Likewise we have drawn the water animals and reptiles. So we are saying that these heights of these bars or these points over here, these represent the frequency or the number of birds present in the zoo. Now in this next question, the expenditure of a family on different heads in a month is given below. So we are saying the different heads that are given, they are food, education, clothing, house rent, other expenditures, and savings. And the values they are given in thousands over here. In K means here this K is present in, it is in thousands. So what we are saying that these values, these are given to us. Now what we have to do is we have to draw the bar graph to represent the data. So again on the x-axis we have marked the heads. Heads means we are talking about this first one, this represents food, this second represent education, this third represents clothing, this represent house rent, next is others, and this is savings. And the values we have it is 4,000, 2,500, 1,000, 3,500, 2,000, and 1,500. So it is difficult to draw all these points if we start drawing from 0. So what we are going to do is, suppose we are marking this point at a distance of 500 units. Why we are saying the minimum value over here it is 1,000, the maximum value over here it is 4,000. So range of this data it is 3,000. And how many units we can mark? Say at we are saying if we mark at the 500 distance, then we get it is 6 units. We have to mark 6, then 0 will be there and one more unit will be there. So 7 or 8 units we have to mark. So you can also mark at a distance of 1,000, that is 1,000, then 2,000, then 3,000, then 4,000. You can mark in this way also, then you have to mark only these. After 0 you have to mark these 4 points. So it is up to you that how you want to mark, but in this question we have marked it like 500, 1000, 1500, 2000, 2500, 3000, 3500 and 4000. So now what we have is that for food the expenditure is 4000. So for food we have drawn this bar over here, and the height of this bar is up to 4000. Next, for education the value is 2500, so we have drawn this bar up to 2500. Next, for clothing it is 1000, so we have drawn this bar over here up to the height of 1000. Likewise, we have drawn house rent, others and savings. So this is the required bar graph to represent this data. Now the next is the following table gives the frequency of most commonly used letters A, E, I, O, R, T and U from the page of a book. So we are saying A, how many times A is used? It is 75. E is used 125. I is used 80. Likewise, O, R, T and U, these are used 70, 80 and 95 and 75 times. We have to represent this information on the bar graph. So we are talking about, this is the x-axis over here. On x-axis we are representing the letters. This is the y-axis over here, and on y-axis we are representing the frequency of these letters. So we are talking about the x-axis. The letters we have, it is A, E, I, O, R, T and U. On y-axis we are saying the minimum value we have over here, it is out of these values we are saying the minimum value it is 70, and the maximum value we have, it is 125. So what we can do is we can draw this graph in this form also. We are talking about this graph in this form. So we are saying these points, we are saying this is A, E, I, O, R, T and U. This is our x-axis, this is 0, and this axis we are saying it is y-axis. Now we are saying our point, it is starting with 70 and ending at 125. So we can mark these points at 10 unit distance. Now in place of starting it with 10 over here, we are suppose we are saying this point is 70. Next this point is 80. This point is 90. This point is 100. This is 110, 120 and 130. Now what problem is there is that after 0 we are just writing 70. So to remove this problem, this region, this is representing 70 points over here. So in place of joining these 2 points in this form, what we do is we join these 2 forms in this way. That is, we put a link over here. In place of we are doing it like this, that this is what this is representing, that this is not all the length, these are not uniform. Basically we are saying this is representing that there are 70 points between these two, and if we enlarge this, this is just like 60, 50, 40, 30, 20 and 10. All these points, these are lying in between these 0 and 70. This much portion is lying over there. So if we draw in this form, then for A we have, it is 75. So 75 means we have to draw it like this. Then next E is 125. For E we will draw it like this. This is up to 125. This is up to 75. Next I is up to 80. So up to 80 means we are talking about I is up to 80. Then next O is up to 70. Like this we can draw the other points over here. Or if we are drawing the points in this form, we have shown over here, it is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and the points on the y-axis we have marked in this form. Then at A we are having 75, B we are having 125. So basically both these values, these are representing the same thing. It is 125 over here, this is representing 125. This is 75 over here, this is representing 75. So based on this thing, that how we are representing the y-axis, the corresponding bar graph will change, but the basic information that it will contain, it will be the same. So if I'm talking about point O, I will join this O over here and I will obtain that the frequency corresponding to O, it is 70, and from this graph also I am getting that the frequency corresponding to O, it is 70. Now next is expenditure on education of a country during a 5-year period from 2013 to 17 in crores of rupees is given below. So these values are given. For elementary education it is 240 crore, for secondary education it is 120 crore, and likewise these values, these are given to us in crores. Now we have to represent the information by a bar graph. So we are saying that along x-axis we have marked the heads, various heads we have, and along y-axis we have marked the corresponding expenditures. So these values are shown over here in the graph. So we are saying on x-axis we are having the different heads, that is elementary education, secondary education, university education, teacher training, social education, other educational program, cultural programs, and technical education. Now how we are going to draw this? For we are saying for elementary education we have spent 240 crore rupees. So we have marked these points on the y-axis, that is expenditure in crores of rupees. So we have marked at a distance of 2 units. So it is 20, 40, 60, 80, 100. Like this we have marked these points on the y-axis. So what we have is that elementary education, the amount spent is 240. So for elementary education we have drawn this bar up to 240. So saying this is, we have drawn up to 240. Then secondary education we have drawn it up to 120. This thing we are talking about, we have drawn it up to 120. Likewise we have drawn the other points over here, that for university education it is 190, for teacher training it is 20, for social education it is 10, for other educational program it is 115. So 115 will lie somewhere over here below 120. Then next we have it is 25, and last we have it is 125, and 125 will be somewhere over here above 120. So this is how we can represent this data on the bar graph. Now the next thing we have is how to read the bar graph, and for this we are talking about that given is a bar graph showing the heights of 6 mountain peaks. Read the diagram and answer the following questions. Which is the highest peak and what is its height? So if we look at these, what is given to us is that on x-axis mountain peaks are given and height of these mountain peaks is on the y-axis. So we have to find the highest peak. Highest peak means that its height should be maximum. So for all these graphs the highest height is 8,800, and this is corresponding to the Mount Everest. So what we get is Mount Everest is the highest peak and its height is 8,800 meters. Next is write down the ratio of the height of the highest and the lowest peak. Now lowest peak, the lowest value of all this, it is 6,000. It is this peak we are talking about. This is corresponding to this mountain. So the ratio of these two will be 8,800 is to 6,000, and the answer comes out to be 22 is to 15. So this is the ratio of the highest and the lowest peak. Write the heights of the given peak in ascending order. Ascending order means first of all we have to write lowest. So it is 6,000. After that it is 6,500. After that it is 7,500. Then it is 8,200, 8,600 and 8,800. So these are the answers that we have, that if we write the heights of the peak in ascending order, you can see that from this graph it is easy to see all these values. Now the last is which peak is the second highest and what is its height. So second highest means this is the highest one. Second highest peak is with the height 8,000 600 and its name is Kanchenjunga. We are talking about this is 8600. So what we get is that Kanchenjunga is the second highest mountain after Mount Everest, or peak after, it has the second highest peak after Mount Everest, and its height is 8600 meter. Next is, in a survey of 85 families of a colony, the number of members in each family was recorded and the data has been presented by the following bar graph. Read the bar graph carefully and answer the following questions. First is, what information does the bar graph gives? So this bar graph tells us that number of members in the family and number of families. So basically we are talking about that how many families are there which have 2 members, 3 members, 4 members and 5 members. This bar graph tells us that how many families are there that have 2, 3, 4 and 5 members. This is the answer for our first part. Second, how many families have 3 members? So we are talking about number of members we have to calculate is 3. So how many family means we are talking about this bar over here, this bar over here, and if we join it with the y-axis, that is the number of families, they are represented on the y-axis. So we have get the answer, it is 40 families have 3 members. Now the next question we have, it is, which type of family is the most common? How many members are there in each family of this kind? So most common means that we are saying that most common means we are talking about there are 40 families, we are saying this 40 families are there which have 3 members. So most common is the family having the 3 members. And how many members are there in each family of this kind? It is 3 we are saying. Now next we have, read the given bar graph and answer the question. What information is given by the bar graph? So to see what information is given, we look at the x-axis over here. So on x-axis it is years is given, production of food grain in Indian states during 5 consecutive years, and on the y-axis we have production of food grain in million tons. So we are saying what this bar graph is telling us, it is giving the information about the production of the food grain in Indian states during 5 consecutive years from 2013 to 2017. This is 2013 to 2017. Second is, in which year was the production maximum? So we can see that this is the bar with the maximum height. So we are saying that in the year 2015 the production was maximum. Third, after which year was there a sudden fall in the production? So we can see from this that in 2015 up to 2015 the value is rising, from 2013 to 14, 14 to 15 the value is rising, then suddenly the value is decreased over here. So we are saying that after the year 2015 there is a sudden fall in production. Then next is, find the ratio between the maximum production and minimum production during the given period. So the maximum production means we are talking about, it is in this year 2015 and its value is 100 million tons, and the minimum production we have, it is in the year 2016 and its value is 40 million tons. So we have to find the ratio between maximum and minimum. So we are saying it is 5:2. So this is represented in our next slide, that the answer we are getting over here, it is the ratio of the two values, it is 5:2. Now the next thing we have to study is the histogram and frequency polygon. So last thing we have done, it is bar graph. Now the next, it is histogram and frequency polygon. So a histogram is the graphical representation of a frequency distribution in inclusive form. It is important over here that the frequency distribution is in inclusive form, and it is in the form of rectangles with class intervals as bases and the corresponding frequencies as heights, there being no gap between any two consecutive rectangles. This is the definition we have. We will see what is the meaning of this definition with the example. So first of all, we will look at what are the steps of drawing the histogram. So first thing is that we have to convert the frequency distribution in an inclusive form. So whatever the frequency distribution is given to us, we have to convert it to the inclusive form. If it is in the inclusive form, we need not to do anything. Next, we take a suitable scale and mark the class intervals on the x-axis. Then next, by taking the suitable scale, we mark the corresponding frequencies on the y-axis. You will see what we are talking over here with the help of our next example. And last thing we have to do is we have to construct the rectangles with class intervals as base and the corresponding frequencies as height. So these steps and the definition I am going to explain with our next example. So first thing is histogram when the frequency distribution is in exclusive form. So we are saying represent the following frequency distribution by means of the histogram, and the values they are given as 10 to 20, 20 to 30, then 30 to 40, 40 to 50, 50 to 60, and 60 to 70, and 70 to 80. So what this thing means is, if suppose I am talking about marks between how many students have marks between 40 to 50, then the answer you will give it is, this is between 40 to 50 there are 13 students. This is exclusive form. Exclusive form means that 50 is not included over here but included in this. The value of 50, it is included in the next interval and not in 40 to 50. So what our first step was saying, it is that first of all we have to convert it to the exclusive form. So data is already given in the exclusive form. Next thing, we have to take a suitable scale to mark the class intervals on the x-axis. So scale is very clear over here that it is 10 to 20, 20 to 30, 30 to 40. So we have marked these points on the x-axis. We have started, it is 0 over here, then 10, 20, 30, 40, 50, 60, 70, 80 and 90. These are the points we have marked on the x-axis, and these represent the marks that are obtained. Then on the y-axis, we are talking about the number of students. So number of students, we are saying the minimum frequency we have it is 2 and maximum it is 16. So we mark the points like this, 1, 2, 3, 4. If suppose it is not possible to mark the points in this form, then you can mark it like 2, 4, 6, 8, 10, 12. Then and that is for 1 unit you can mark the points like this, or you can mark the points like 4, 8, 12, 16. You will require only 4 points in this case. So on the y-axis we have marked the number of students, that is we are talking about the frequency, and on x-axis we have marked the marks. Now what our next step is saying, that construct rectangles with class intervals as bases and the corresponding frequencies as height. So first class interval we have 10 to 20 and the frequency we have it is 7. So what we are going to do is, corresponding to 10 to 20 we have drawn this rectangle over here, and this is representing 7. For the next we are saying 20 to 30 it is 11. So for 20 to 30 we are saying this is 11 over here. Then next we are saying it is 30 to 40. For 30 to 40 we have the value over here, it is 9. Then 40 to 50 we have drawn this over here, and the value we have it is 13. So like this we will draw the bar graphs, bars we can say, or rectangles we are saying. These are the rectangles that we have drawn over here. These are the different rectangles we have drawn, and all these rectangles are joined to each other. In case of bar graph there was a distance between these rectangles, but now all these rectangles, these are joined to with each, these are connected with each other, and this kind of representation of the data, it is called the histogram. Why it is like this? Because if I am saying between 30 to 40, we are saying there are 9. So from 30 to 40, it is representing 9. If I am saying 70 to 80, how many values are there? 2 values are there. So that is why these kind of graph, these are drawn like this, and this is called a histogram. In the previous case, it was the bar graph. Now it is the histogram. Now in this next example, we have to draw the histogram for the following distribution. It is height is given in centimeters. It is 150 to 153, 153 to 156, 156 to 159, like this. And the number of students are given over here, that how many students have height between these two values. So we are saying that we are starting counting the heights over here from 150. So we have marked this over here, because we are saying all other values between 0 to 150, they lie between this point. Next, the minimum height we have it is 6, the maximum height we have it is 14. So on y-axis we have marked this point 0 to 14. These are representing this is representing basically the frequency, and we are saying that is the number of students. So first interval we have it is 150 to 153. So 150 to 153 means we have 7. So we have drawn this rectangle over here from 150 to 153. Next we have marked this point 156. Next we have marked this point 159. So what we are going to do is, we are saying we have marked it like this. We have marked this point 150, 153, 156, 159, 162, 165 and 168. Why we are marking it like this? This thing we know from these values. On the y-axis we have marked the points over here like this. It is this is 0, then 1, 2, 3, 4, like this. We have marked the points up to 15. Now corresponding to the first value, for the first value we are saying it is for 150 to 153, it is 7. So up to, we have to draw the rectangle up to 7. Next, it is from 153 to 156, it is 8. So we will draw the rectangle up to 8. Then next it is 14, we will draw the rectangle up to 14. Next it is 10, so we will draw the rectangle up to 10. So this thing is shown in this figure over here, that how we can draw all these points, that is these frequencies 7, 8, 14, 10, 6 and 5. And these, if suppose I am talking about what is the frequency between, how many students have height between 162 to 165, then we will join these 2 points and we will see that how many students are there. We are saying there are 6 students. So this is what the histogram is representing. Now the next we have is depict the following frequency distribution by a histogram. So the daily wages in rupees are given and number of workers are given. So what this value means, if I am talking about how many workers have wages between 575 and 600, the answer is 30 workers have this wage between 575 and 600. So on the x-axis we are talking about daily wages in rupees. So daily wages, we are saying the value is starting from 500 and ending at 625. So we start with 500 and end at 625 and we mark all these points 500, 525, 550, 575, 600 and 625. These are the points we are marking on the x-axis. This link is there because this portion over here, this represents the values between 0 to 500 and we are not scaling this region. Next we are talking about the number of workers. We have marked the minimum value we have it is 10 and the maximum value we have 30. So we have marked them at a distance of 5 units. So it is 5, 10, 15, 20, 25 and 30. These are the number of workers we are talking about. So between 500 to 525 we are saying 20 workers are there. So we have drawn this box. Next we are saying between 525 to 550 there are 15 workers. So we have drawn this box. Next, between 550 to 575 there are 25 workers, so we have drawn this box. So in this way we have drawn these next two boxes also. Boxes you can say, or you can say rectangles we have drawn over here. And this whole figure we are saying, this whole graph, this is the histogram corresponding to the given frequency distribution. Now the next case we have, it is histogram when frequency distribution is in the inclusive form. Inclusive form means now the values that are given to us is, this is 10 to 17, the next is 18 to 25. So what we have over here, that 10 and 17 both are included. So we have to convert this into the exclusive form. So to convert it into the exclusive form, what we are going to do is, we are saying we are going to find the true class limits over here. So true class limits in this case will be, we will subtract, this is 10 to 17, then 18 to 25, then 26 to 33, like this. Now we have to calculate true class limits. It means we have to subtract 0.5 from these values, and we have to add 0.5 to these values. So the true class limit corresponding to this is 9.5 to 17.5. Corresponding to this is 17.5 to 25.5. This is 25.5 to 33.5, and so on. And these frequencies will not change, because if we are saying how many values are between 26 and 33, we are saying it is 740. So how many values are there between 25.5 and 33.5? It is also 740, because there is no value between 25 and 26 and 33 and 34. There is no value between these two. So these are the number of values between 25.5 and 33.5. So the table that is given to us, that is age group in years and number of females. So this table is converted into the exclusive form in this way, that it is 9.5 to 17.5. What is the frequency? It is 300. Similarly, from 17.5 to 25.5 it is 980, and likewise we get all other values. These are the all other values that we will get. Now this is the table that we have obtained in the exclusive form. So now we know the procedure, that on x-axis we are talking about the age group. What are the values we have? It is 9.5, 17.5, 25.5, 33.5, 41.5, 49.5 and 57.5. These are the frequencies that we have, and frequencies we are marking on the y-axis. So we have marked these points. The scale we have used over here, it is that 1 unit over here, this is representing 100. Then we have drawn the corresponding rectangles, that from 9.5 to 17.5 it is 300. Then 17.5 to 25.5 it is 980. Then next we have from 25.5 to 33.5 it is 740, and likewise we can draw the corresponding rectangles over here, and we obtain the histogram corresponding to the given data that was given in the inclusive form. So first we have converted into exclusive form, and then we have drawn the histogram. Next we are saying the length of 62 leaves of a plant are measured in millimeters, and the data is represented as the following table. Now when we look at these values over here, the first interval we have 118 to 126, next it is 127 to 135. So this given data, this is in the inclusive form, and we have to convert it to the exclusive form. And we know how we convert the values. We subtract 0.5 from this, and we add 0.5 to this value. So our value changes to 118 minus 0.5. 118 minus 0.5, it is 117.5, and 126 plus 0.5, it is 126.5, and the frequency we have it is 8 over here. So these frequencies we are talking about 8, 10, 12, 17 and 7. These are not changing over here. These are the frequencies that are given to us, and these values, these are changing. And how these are changing, suppose I am talking about this, so it is 154 minus 0.5, 162 plus 0.5. so what we get is 154 minus 0.5 is 153.5, and this is 162.5, and the corresponding frequency we have it is 7 over here. So to draw the histogram, what we are doing is we have marked the length of leaves on the x-axis, and we have marked the number of leaves on the y-axis. On the x-axis we have marked all these points: 117.5, 126.5, 135.5, 144.5. we have marked all these points over here. These are the points that we have marked over here. And the number of leaves we are saying it is, the minimum value we have it is 3, and the maximum value it is 17. So we have marked these points on the y-axis. Now corresponding to these values we have drawn the corresponding rectangles over here, that it is 8, then 10, then 12, then the height is 17, then this height is 7, 5 and 3. These values we have drawn corresponding to these frequencies, and these intervals we have drawn these values, and we obtain the histogram in this form. Now the next we have, it is histogram when class intervals are of unequal size. So in this case, the class interval, we have to calculate the adjusted frequency by using the formula. It is adjusted frequency is equal to, this is the formula we have, minimum class size over class size of this class into its frequency. So what we are going to do is, suppose we are talking about the following frequency distribution of total marks obtained by the student of all section of a class in an examination are given. So the intervals we have it is 100 to 150, 150 to 200, then 200 to 300. So if we look at the class intervals over here, so it is 50. In this class interval it is 200 minus 150, it is 50. Over here the class interval is 100. Over here the class interval is 200, and over here the class interval is 300. So what we have is that the class intervals are of unequal size. Now we have to draw the histogram for this case. So in this case we are saying what we have to do is, the minimum class size that we have it is this 50. So the height of the rectangle for a given class interval, that is equal to its frequency into its width into 50. So if we are talking about this first interval, so its width is 50. So what we get is that the frequency corresponding to it, it is, we are talking about this first interval over here. We look at this next slide. So it is 100 to 150. So width of class is 50, and the formula we are using it is, this is the frequency over width of the class, it is over its width into 50. Similarly in the second case, both these 50 and 50 gets cancelled, we are left with 60. Similarly in the next case we are having the width of the class is 50. So again the frequency we are getting it is 100. Now in the next class we are talking about from 200 to 300, we are having the frequency 100. Width of the class is 100. So we are saying when we use this formula, it is 100 over width of the class into 50. The answer we are getting it is 50. So height of the rectangle that we have to draw in the histogram, it is 60, 100, 50. Similarly in the next case the value will be 20 and this value will be 30. Now we have, these are the heights of the rectangles that we have to use. So the scale we are using over here, these are the intervals we have. So on the x-axis we are talking about the marks or class intervals, and on the y-axis we are talking about the height of the rectangle. So what we are saying, the first class width is 50, it is 100 to 150. So we have marked these points over here: 100, 150, 200, 300, 500 and 800. These points we have marked on the x-axis, and the height we require, it is 60, 150, 20 and 30. So we have marked with a distance of 10 units. So these are the heights we have marked, it is 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So the frequency over here, it is 60, the class width is 50 and the adjusted height of the rectangle, it is 60. So at 100 we have drawn, from 100 to 150 we have drawn this rectangle, and its height we are saying it is 60. Now second, it is 150 to 200, we have drawn the height, it is 100. Now in the next case we are saying that the class interval is 200 to 300. We are talking about this class interval over here. So the width of this rectangle, we are talking about the width of this rectangle, it is 100. It is the width of this rectangle, it is 50. Width of this rectangle, it is 50. So the width of this rectangle is 100. So the frequency we are using over here, it is this we are talking about. This value we are saying we are using over here, it is 50, and it is not 100 that we are using. We are not using the frequency as 100, we are using it as 50 because the width of the rectangle is now doubled. Similarly, in the next case, we are saying the width of the rectangle we have, it is 200. Over here the width of the rectangle is 50, now the width of the rectangle is 200. So in place of 80 we are using the frequency is 20. This is 20 we are talking about. And then next we have the width of the interval over here, it is 300. So we are saying the frequency we are having over here, the adjusted frequency we are having over here, it is 30. So height of the rectangle that we have taken, it is 30. So if we look at this rectangle over here, this rectangle we are saying the total, what we mean to say is we are considering it like this, that from 500 to 550, 550 to 600, 600 to 650, 650 to 700, 700 to 750, 750 to 800. So basically we are talking about 1, 2, 3, 4, 5, 6 rectangles over here. Now if I am talking about 180, so we have basically divided 180 by 6 and the answer we are getting, it is 30. So this is how we draw the histogram when the class intervals are of unequal size. Next we are given a random survey of the number of children of various age groups playing in a park was found as follows. So these are the age in years and then the number of children are given. So if we are talking about the age over here, the difference in these two values is 1, difference of these two values is 1, difference of these two values is 2, then it is 2, this is 3, this is 5 and this is 2. So what we see is that the class intervals we are talking about, they are of unequal size. Unequal size means that these differences over here, these all differences, these are of, these differences they are not these all age groups that are given, they are not having the same difference, they are having different differences. So again the minimum value over here, it is 1. So height of the rectangle of a given class, the formula that we will have, it is its frequency over its width into 1. So for each of these case, what we will get is, for the interval 1 to 2, the class width is 1. So both these frequencies we are talking about, both these values, these are 5. In the next case it is 1. So both these values, these are 3. Now in the next case we are talking about this value is 2, this value is 2. So by using the formula we get it is 6 by 2 into 1, that is equal to 3, and this given value it is 6. Similarly for 12 we apply this formula, we get the value is 6. Next for 9 we get the value is 3, because the width of this class over here, it is 10 minus 7 is equal to 3. This is the width of this class. It is 5 minus 3 is equal to 2. It is the width of this class. Similarly for this, the width of the class is 10, 15 minus 10 is equal to 5. So 5 is the width of this class. Frequency over here it is 10. So adjusted frequency we get it is 10 over 5 into 1. Why this 1? Because 1 is the minimum width that we have of the classes. Similarly for this value, the width is 2. So the answer we are getting it is 2 over here. So in this question again, along the x-axis we are talking about age in years. So age, these values we are taking over here. What values we have to take on x-axis? It is 1, 2, 3, 5, 7, 10, 15 and 17. So we have marked these values over here at the equal interval, that is 1, 2, 3, then this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And on the frequency side we are having the values 5, 3, 3, 6, 3, 2 and 2. So the maximum value we have it is 6. So number of children we are saying, that is the frequency we are talking about. This is basically the frequency along y-axis. So number of children we are talking about, they are 0, 1, 2, 3, 4, 5, 6, because the maximum value we have 6 over here. So the first rectangle that we will get it is, the interval is 1 to 2, class width is 1 and the frequency is 5. So with frequency 1, the class width 1, this is the frequency 5. Next it is 2 to 3, again the class width is 1 and the frequency is 3. So it is 3 over here. Now in the next case, the width of the class it is 2. So it is 3 to 5. So we have marked it is 3 to 5. So this box over here we are talking about. Over here the difference is 1. Over here the difference is 1. In next difference we have 2. Next difference we have 2. Next difference we have 3. Next we have 5. And this difference we are saying it is 2. So the frequencies we are using over here, for this 3 to 5 we are talking about. For 3 to 5 the frequency we are using it is 3. Next for 5 to 7 the frequency we are using it is 6. Next for 7 to 10 the frequency we are using it is 3. And then for the next two values we are talking about 10 to 15, the frequency we are using it is 2. And then for 15 to 17 the frequency we are using it is 2 over here. So we are not using these frequencies, but we are using the adjusted frequencies. You can say these, you can say these are adjusted frequencies, or we are saying these are height of the rectangles that we require to draw the histogram. So the formula that we are using over here, that is the frequency that is given to us. We are talking about this frequency over the width, these values we are talking about, and multiplied by, we are talking about this is the width, and multiplied by the minimum frequency, or we are talking about the minimum width that we have to multiply it with that particular value. Now the next thing we have is the frequency polygon. So first thing that we have drawn, it was the bar graph. Next we have drawn the histogram. Now the third thing that we have, it is the frequency polygon. So we are saying that x1, x2, x3 so on up to xn be the class marks. Class marks means we are talking about the midpoint. Midpoint means I am talking about if the interval is given to us. Suppose the first interval that is given to us, it is 0 to 10, next is 10 to 20, next is 20 to 30. So class marks means we are talking about midpoint over here. So midpoint is 0 plus 10 by 2, that is 5, then 10 plus 20 by 2, that is 15, then 20 plus 30 by 2, that is equal to 25. So these values we are saying these are basically the midpoint of these intervals, and these are called the class marks, and these are basically the midpoint. So we are saying let x1, x2, x3, xn be the class marks of the given frequency distribution, and let f1, f2, f3, fn be the corresponding frequencies. So we are saying some intervals are given to us. Corresponding to it, we are talking about the class marks are x1, x2, x3, x4, x5. Class marks means we are talking about midpoint. Midpoint means if the interval is a to b, midpoint means a plus b by 2. And the frequencies we have over here, these are f1 corresponding to x1, corresponding to x2, corresponding to x3, corresponding to x4, and corresponding to x5. These are the frequencies. Now if we plot these points, means we are talking about x1 comma f1, x2 comma f2, xn comma fn. If we plot these points on the graph and join these points by line segments, this is important over here that we have to join them by line segments, and we complete the diagram in the form of a polygon by taking two more classes, the imaginary classes we are saying, one at the beginning and other at the end. Then this polygon is called the frequency polygon. So in the next slide we will see what is the procedure to do this with an example. So first of all we are talking about the method. So method we are saying first of all we have to calculate the class marks, that is the midpoints. Then along the x-axis we will take the suitable scale to draw these points, to mark these points. Then on y-axis we will draw the frequencies. Then we will join the points x1, f1, x2, f2, x3, f3 by line segments. This is important over here that we have to join by line segment, that is we have to use the scale. We have to use the straight lines to join these points. Then take two class intervals each of frequency 0. We are talking about two class intervals we have to take, and one at the beginning and the other at the end of the frequency table. Find their class marks. These are called the imagined classes or imaginary classes. Now join the midpoint of the first class interval to the midpoint of the imaginary class, and the midpoint of the last class interval to the midpoint of the imaginary class at the end. We have to join these points. So we will see how we use this procedure with an example. So we are given the following table shows a frequency distribution for the speed of cars passing through a particular spot on a highway. So we are saying the speed of car, number of cars between whose speed is 30 to 40 is 3, between 40 to 50 it is 6, 50 to 60 it is 25, like this. These are the class intervals for the speed, and these are the frequencies that are given to us. So we have to draw the histogram and the frequency polygon representing this data. So for the frequency polygon we require the class marks over here. So class marks are, we are saying corresponding to 30 to 40, the class marks is 35. Corresponding to 40 to 50 it is 45. How we are calculating these values? We are saying it is 30 plus 40 by 2, so that is equal to 35. Suppose I am talking about this particular class, then what we are doing, it is 80 plus 90 by 2. The answer you will get, it is 85. So this is the class mark over here. Then these two intervals, this and this, these two intervals we are saying these are imaginary intervals. Imaginary interval means that the actual data that is given to us is from 30 to 100. The values that are given to us, these are from 30 to 100. And we have added these two classes over here. One is 20 to 30 and one is 100 to 110. And the frequency of these two classes we have taken, it is 0. The class marks for these interval, it is 25 and 105. The how to calculate the class mark, it is same, it is 100 plus 110 by 2, so that is equal to 105. So these are the class marks corresponding to this class interval. So we are drawing the histogram as well as the frequency polygon. So what we have is that the class intervals over here we have, it is 20 to 30, class mark is 25, frequency is 0. Then 30 to 40, we are seeing class mark is 35 and frequency is 3. So we have drawn this histogram over here, that from 20 to 30 it is 0 over here. Next 30 to 40, it is this value over here, that is frequency is 3. Next the frequency is 6. Next the frequency is this over here, we are talking about the frequency at this point, it is 25. So how we are drawing this? On the x-axis we are taking the speed. The points we are marking over here, these are these points 20, 30, 40, 50 up to 100, 10. On the y-axis we are talking about number of cars, and the maximum number of cars we have, it is 65. Minimum we have, it is 0. So we have marked these points on the y-axis. Then we have used these frequencies 0, 3, 6, 25, 50, 28 and 14 to draw this histogram. Now next thing we have to do is we have to join the midpoints. Class marks are 25, 35, 45. So what we are going to do is, these histogram we are talking about, and we have marked the midpoint of these histograms. This is the midpoint over here, this B is the midpoint over here, C is the midpoint over here, D is the midpoint over here, E is the midpoint over here. Now if I look at this point E, so what we get is, if I look at this value over here, this will be the midpoint. Midpoint means this will represent 65, and what is height of E over here? We are saying it will be its frequency is 65. Its frequency is also 65. If I look at this point G over here, we are saying what this midpoint is representing? It is representing 85, and the frequency we get, it is, if we join these 2 points over here, the frequency corresponding to it is 28. So what we have to do is, we are talking about, we have drawn the histogram and then we have marked the midpoint of all these intervals, and finally we have joined these points with the help of scale. This C and D, then D and E we have joined with the scale, E and F we will join with the scale, F and G we will join with the scale, G and H we will join with the scale, and H and I. This I and A, again we are talking about this I and A, these are the imagined intervals. But it is important to note that we always draw these 2 points so that it becomes a complete polygon. So we will start it from the point A and we will end it on the point I on the x-axis, and rest all the points we have obtained. And this polygon that we have obtained, polygon means we are talking about, this is A to B, then B to, say A to B, then B to C, then C to some point over here, then some point over here. It has reached this point, then it has reached some other point, it has reached this point, and these 2 points we are saying. So we are getting something which is having the sides like this, straight lines we are having. So that is why it is called a polygon. So this is the required frequency polygon. This A, B, C, D, E, F, G, H, I we are talking about, this is the required frequency polygon. Now in the next question we are being given the daily pocket expenses of 150 students in a school are given below, and we have to construct the frequency polygon representing this data. So we are not supposed to draw the histogram over here, so we have to directly draw the frequency polygon. So we are saying the class intervals are given to us, and the class intervals they are starting from 50 to 60 and they are up to 100 to 120. So it is 50 to 60, 100 to 120 we are talking about. This value is here and this value is up to this. So we are saying we have added two intervals over here. These two intervals we have added over here. These are the imaginary intervals, and the frequency corresponding to these two, it is 0. Next we have to draw the write the class marks. So again the formula for the class marks is, for the first we are saying it is 40 plus 50 by 2, that is equal to 45. Next it is 50 plus 60 by 2, it is 55. Suppose I am talking about this, it is 90 plus 100 by 2, so it is 95. So these values, these are the class marks and these are the frequencies. So on the x-axis we are taking the class marks. We are talking about the class marks, they are 45, 55, 65 up to 125. So we have started writing these values from 55. So we have drawn this symbol over here because in this region we are saying we are having the values from 0 to 45. So we are not scaling this region. That is why we are using this symbol. So after these we have the value, it is 45. These are the values on the x-axis we are writing. It is 45, 55, 65, 75 and all these values. And on the y-axis we are having the frequency. This frequency we are talking about, and the maximum value of frequency we have, it is 32. So we have marked it on the y-axis like this, and we have taken the points up to 40 on the y-axis. Now what we have to do is we have to mark these points. It is 45 comma 0. So this is the point 45 comma 0. Next is the point 55 comma 12. So this is the point 55 and this is 12. So this is the point 55 comma 12. Similarly next we have it is 65 and 16, 75 and 25, then 85 and 20, 95 and 32, 105 and 27. These 2 points we are talking about. Then 115 and 18, and the last point we have it is 125 and 0. Now the next step we have to do is we will join all these points with the scale. We have joined A, B, D, C, C, D, D, E, E, F, F, G, G, H and H, I. We have joined all these points with a scale, and this polygon that we have formed, this is the required frequency polygon. So we have not drawn the histogram over here, we have directly drawn the frequency polygon. If the histogram is being asked, then what we have to do, we will draw the, this is point 40 to 50, and we will draw the rectangles like this. Then it is 50 to 60, we will get the next rectangle like this, and these points will be the midpoints over here. But we do not need to draw the histogram. We are directly drawing the frequency polygon as it is asked in the question. Now in this question we are being asked draw the frequency polygon representing the following frequency distribution. So the distribution given over here, it is 30 to 34, these are the class intervals, then 35 to 39, then 40 to 44, then 45 to 49, then 50 to 54 and 55 to 59. So what we see from this, that we find the intervals given over here, they are in the inclusive form. So either the intervals given, they are in the inclusive form or they are in the exclusive form. That will not change the frequency distribution. The method to find the frequency distribution, the method will remain the same. So the first thing we have to do is we have to find the class marks. So corresponding to 30 to 40, we are saying these intervals we are talking about, this is 30 to 40. We have written it over 30 to 34, and the last interval we have it is 55 to 59, and these are the corresponding frequencies. Next we are talking about, we have added an interval over here, it is 25 to 29, and after this we have added the interval 60 to 64. We are talking about these two intervals. We have added these two intervals. These are the imagined intervals, and their frequencies are 0 and 0. So class marks corresponding to these intervals, it is when we are calculating this, it is 25 plus 29 by 2. So answer we are getting it is 27. Next it is 30 plus 34 by 2. The answer you will get it is 32. Suppose I am talking about this interval. So it is 45 plus 49 by 2. The answer I will get it is 47. So this is how these class marks, these are calculated. These class marks, these are calculated using the formula that if these intervals we are saying, these intervals they are of the form A to B, then the class marks we calculate A plus B by 2. These are the values of class marks that we have. Now on the x-axis we have to mark the points we are talking about. These are the class marks, and on x-axis we have to mark these points. These class marks we have to mark, and on the y-axis we are having the maximum value over here, it is this 20 frequency, the maximum value of frequency we have 20. So on the y-axis we have marked the values of frequencies. These are the values of frequencies that we have marked on the y-axis. So now the points that we have to plot over here, the first point is 27, 0. So we have plotted this point 27, 0. The next point we have to plot it is 32, 12. This is the point 32, 12. Next is 37, 16. This is 37, 16. Next is 42, 20. This is the point 42, 20. Next is the point 47, 8. So this is the point 47, 8. And likewise we will draw all other points F, G and H. H is the point 62, 0. So this is the point 62, 0. Then in the final step what we have to do is we have to join all these points using the straight line. We have joined A, B, B, C, C, D, D, E, E, F, F, G and G, H. All these points we have joined using the scale, or we are saying we have to join these all using the scale, using, that is, we have to join all these with the straight lines. Now this is the required polygon. We are talking about this is the required polygon. Now in the next question we are given the two table of distribution of students of two sections according to the marks obtained by them. So we are talking about two sections are there. This is section A, this is the marks of section B. So this is the frequency distribution given to us. Marks between 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. These are the frequencies for the students of section A, and these are the frequencies corresponding to the students of section B. We have to draw the frequency polygon for both these cases. For both the cases we have to draw the frequency polygons. So when we are talking about the class marks, we are having the intervals over here 0 to 10. So class mark will be 0 plus 10 by 2. So that will be 5. Next it is 10 to 20. So class marks is 10 plus 20 by 2. So that is equal to 15. So the class marks we have obtained it is 5, 15, 25, 35 and 45. The frequencies we have it is corresponding to the section A, and these are the frequencies corresponding to the section B. So when we plot these points, we are saying on the x-axis we are talking about the, on the x-axis we are saying we are talking about the class marks. These are on the x-axis, and on the y-axis we are saying this is the frequency we have plotted. So class marks, they are 5, 15. These points we are talking about 5. The next point we have it is 15. The next point we have it is 25. Next point we have it is 35. And next point we have it is 45. These are the 5 points we have. And the maximum frequency we have over here, it is 19. So on the y-axis we are plotting the frequencies, and we have taken the points up to 20 over here. The maximum frequency we have 19 over here, so we have taken the points up to 20 along the y-axis. So we have plotted these points over here. So first of all we have plotted the point 5 and 3. This is our point 5 and 3. Next we are plotting the point 15 and 9. So next point we have plotted 15 and 9. Then the next we have plotted 25 and 17. Then 35 and 12, 45 and 9. This is the last point we are talking about, 45 and 9. Now next we have plotted the frequencies corresponding to the point B. So for B, the first we have it is class mark is 5, frequency is 5. So we have plotted the point 5, 5. Next it is 15, 19. Next it is 25, 15. Next it is 35, 10. And last it is 45, 1. These are the points we have plotted. Now the next thing we have to do is we have to point or plot the points that are the imaginary frequencies over there. So imaginary frequencies, in this case it will be, we are talking about the interval will be minus 10 to 0, and over here the interval will be 50 to 60. So for this the class marks will be 55. This is the class mark, and for this interval we are saying the class mark will be minus 5. The frequency for both these cases it is 0. For frequency we are saying both these cases it is 0. So the point we have to mark it is minus 5, 0 and 55, 0. So this is the point we are talking about. This is the point we are talking about, minus 5, 0, and this is the point we are saying it is 55, 0. Then we have joined these points. We are saying A to B, B to C, C to D, D to E, E to F, and F to G. So this is one frequency polygon. And second we have joined the point A to P, P to Q, then Q to R, R to S, S to T, and this is the second frequency polygon. So these are the two frequency polygons that we need to find, or we have to